right? This is a tell function. The tell function returns the current position of the file handler. As I have already told, whenever a file is opened in any of the mode, a file handler is associated with it. The moment you write file object dot tell, it returns the what? It returns the position of the current position of the file handler. Current position of the file handler. Look into this program. It's another way of reading the content one line at a time. We are doing what we are doing. We are reading the content of the file one line at a time. So this is the file which is being present. Suppose this is over here. Demo file.txt is present, and if is the this you can see the file object dot tell. We are using the file object dot tell. This returns what? What is the position, current position of the file handler? The moment you open the file handler points to the beginning of the file. The file handler points to the beginning of the file. That means it returns 0. So it returns 0 to P. So when I print file pointer at, it will print 0th position. It will be present at the 0th position, right? The f6 of 10. So there is a function seek. I will tell you that it will move the pointer to the 10th byte, 10th character, 10th position it will take. It will move the file handler to the 10th position, right? So then if I write f dot tell, it will tell that it's at the 10th position, correct? If I write for x in f, what is f? F is the file handler. If I write for x in f, so f means the content of the file. F is the content of the file. So x iterates over every character of f, every character of f, and it will print that character, right? And print the end of loop. Okay, just a second. Okay, so the file pointer gives the tail function returns the position of the file pointer, correct? And the seek function moves the file pointer. The seek function moves the file pointer. If you want to check it, you can check this program. So go for this /. This file is demo, I believe. This file we have created earlier. The file name is demo, perhaps. This file name is demo. This file is demo.txt, which is on my desktop. So I give it the file name as demo.txt. I open in read mode. Correct. This is the content of my demo file. This is the content of my demo file. Correct. This is the content of my demo file. So I want to open this demo file in read mode. So when I open, the default position of the file handler is at the 0th location. Is at the 0th location. The moment I write p is equal to f dot tell, it returns the starting position and I print it. I move the pointer, then I print, and then I move throughout the file and print each of the characters. So it is nothing but printing the content of the file. So let's run this program. See, uh, try to see the output over here. So f dot, when I open the file pointer at the 0th location, then I move the file to the 10th location and print, then it says that file pointer is at the 10th location. Then this variable x will iterate over each of the character of the file, right? So that the content will be get printed. Now look over here. I have uh, up to the 10th character I have already printed. So the moment I write that for x is in f, so it will start printing from that position itself. From the 11th position character itself it is printing. Correct? It is printing from this. Correct? So the first 10 characters already it has moved. So the if you write for x is in f, the file pointer has already moved. So therefore it will start printing from the current position. So from current position from the s, from this onwards it prints up. Is that understood? Is it understood why it is printing from over here?
Sir, repeat it again, sir. Sir, could not hear properly.
Look here, the file opened in read mode, the first line. This line reads the file. Then when the file is read, the file pointer is at the 0th location. So f dot tell returns 0. So p becomes 0. So it will write file pointer is at 0. Because the moment you open the file, it is at the beginning of the file, therefore it returns 0. Correct?
Yes, sir.
Then I move the pointer to the 10th location. If I write f dot tell, definitely it will print that file pointer is at 10. So next line it prints file pointer is at 10. So what is my file pointer? File pointer is at the 10th location. Now, if I put a loop for x is in f, f is the file. So x will move over f. But what is my current position? Current position is 10. So from 11th onwards, it will print on the screen. Print x, it will print the character on the screen. 11th character, 12th character, 13th character up to the end of the file. So therefore, it starts printing from here. So first 10 character is not printing because it is because my pointer is at the 11th location. Therefore, it will start printing from the 11th onwards. Is that clear?
Yes, sir.
Okay. If you want to refer letter, you can also take a snapshot of this and put it over there in the screen so that later we can also refer it. I'm just putting it over here. When I'll share it, you could able to guess that what is the. I'm just putting the output over here so that later you can refer to this out. Okay. So now we have, so can you execute So the next function is the seek function. The next one is the seek function. What the seek does, it moves the file handler to the desired location. Already I have given the example in the previous case that if you have a seek, it moves the pointer to a particular position. So it moves the file handler to the desired location.
Hello, sir.
Hello.
Clear.
I can't hear you properly. Hello. Can you repeat?
Yes, sir. Okay, sir. Here.
No, I cannot listen properly. Anyway, if you have any query, you can type it because I could not hear you properly. Okay. The seek pointer moves the file handler to the desired location. I have given the example in the previous slide. This example is you just have to write file object dot seek, then offset and whence. Offset is to how much byte you want to move, right? Whence will say that from which position, relative to which position. Okay. So relative to which position, the whence will say. Suppose I write in the previous example f dot seek of 10. That means 10 byte from the beginning. Seek of 30 bytes from the beginning. But if I want to move 30 bytes from the last or from the current position, then what to do? Are you getting me? Seek dot 10 moves 10 byte, but this 10 byte is always from the beginning. Seek of 30 will move 30 bytes from the beginning. But if I want to move from the end or from the current position, right? Then I have to, then the whence will come into act. Then the whence will be useful over there. Then the offset gives you the value. Offset is the position of the read or write pointer within that file. That is the offset. The whence will say, whence is optional and default is 0. This value default is 0. You can see over here, I have not given whence. So therefore, the default value is taken as 0. What is 0? 0 is the absolute file positioning. So it is always at the beginning of the file. Absolute file positioning is at the beginning of the file. So if I want to read from the current position, suppose I am the 10th location, I want to move 5 bytes from the current position. So what will write? 1. Seek relative to the current position. So if I write f dot seek 10, 1, that means 10 bytes from the current location. 5, 1, 5 bytes from the current location. If I do not give anything, it is 0 from the beginning of the file. So 0 is from the beginning of the file. 1 is from the current position. 1 is from the current position and 2 is relative to the end of the file. So if I write, that means if I give 2, definitely my offset will be what? Can anybody say what should be my offset? If my whence, it should be -5. Why it is there? Because I am going in negative direction. So if it is in end of file, I will have to give the negative value in the offset, right? So see over here. Let us take an example over here for the seek function. So I open a file. Suppose the file is work file. You can give any name over here. I open in write mode and B for binary. So remember, you have whatever the modes you have read already. You have read the read, write, append, R plus, W plus, A plus. These modes I have only told. Besides that, there is a binary file I have told, text file and binary file. For binary file, what you have to do, along with this mode, you just have to add B. That means RB, WB, AB or RB plus WB plus AB plus in this. So if you add the second character B, you add to the file opening mode, then that file becomes a binary file. Correct? Although we have not yet read the binary file, just you remember that if you want to write into a binary file or read from a binary file, the file has to be opened in binary mode. File has to be opened in binary mode. Right? So for example, this is the file I have opened for writing purpose. And it what kind of file it is? What kind of file it is? It is a binary file. It is a binary file. We want to open it for writing. Then we write something over here. Then we write something, the binary data we write into the file. This is B we have written. As you know that B for the binary. So this data we have written into this file. This work file I want to write this. So these things will be written as not as a text, rather as a binary to this file. I close the file, right? And I open it again for reading. As the file is created in binary mode, so therefore the same file I open in read mode as well. So file I have opened in binary mode for writing, the same file I open in read mode. Correct? So if I write f.seek5, f.seek5, go to the 6th byte in the file. 6th byte in the file means it is actually over here. Just look over here. Suppose I write f.seek5 and then I write f.read. f.seek5, then I write f.read. So what it will print? 4, 1, 2, 3, 4, 5. So it will start printing from here. 5, 6, 7, 8, 9, 8. Because my file pointer is over here. Let me.
Sir,
My file pointer is over here. Correct?
hello, sir. Sir, in the binary mode, sir, actually when you access the file, it will be in the binary format or in the text format?
The binary format. Binary does what does binary mean? Binary means
Zero
the
one
way.
format.
No. Binary file I have already told you. Binary means the way it is stored in memory, in the same way it will be stored in the file. Suppose 123.67. So 123.67 has a floating point representation in the memory. The way it is represented, the same way it will be written into the memory. The way it is being stored in memory, it will be stored in the file. But if you go in the text file, 123.67. So how many characters? 1, 2, 3 point is a character, 6 is a character, 7 is a character. So all these will be 6 bytes it will take in the file. But
Yes,
in
sir.
binary mode, as it is a float, it will take only 4 bytes.
Yes, sir.
Okay. So anyway, just see over here. Whether for the timing, even if it is not a binary file, you don't need to be worried. So as I have given this f.seek of 5, f.seek5, that means my file pointer will move 5 bytes. Just see over here, 1, 2, 3, 4, 5 bytes. So up to this, the file pointer has already read up to this. So that means whatever the operation I will do, it will be from the 6th location onwards. It is not from 5th. It is from the 6th location onwards. Correct? So now my file pointer will read from this point onwards, from this 5 onwards. This is 5 is nothing but the 6th byte. So this 5 bytes already it has read. It has read these 5 bytes. 3, 4, sorry, these 5 bytes. It has read these 5 bytes. Let me clear it again. So it has read these 5 bytes. Correct? My file pointer is over here. The moment I write f dot read, it reads from this onwards, from the 6th byte onwards. And that is the reason for which I get the output as this one. Achha, so my position is over here, right? So if I write f dot seek of 5, can you tell from which location it will go to? F dot seek
from the beginning.
From the beginning. So this is exactly same what I have written over here. The meaning is same. That means again it is over here from the 5th byte. So if I type printf f dot read of 1 means 1 character I want to read. So which character it will read? It will read only 1 character. It will read from, is only read 1 character from here. Correct? Because I have given 1. Because I have given 1, so that therefore it will read 1 character and that character is 5. Okay, but for the same value, if I give f dot seek -3 2, f dot seek -3 2, I already told 2 is for what? 2 is for
From the
end of file.
Reading from
And
the end of the file.
yes, end of file. So 2 is for the end of file. How many characters? 3 characters. So 3 characters from the end of file. 3 characters from the end of file. So the output is D, E, F. And the same command f dot seek of -3 2, but if I give only 1 character to read, so -3 it will move over here. So if I give 1 character to read, it will read this D only. Is that clear? So we have 2 important functions actually. These 2 are very important functions because this seek and tell will move, seek function will move the pointer, file pointer inside the file. And tell function returns the current position of. So you can use the tell function after this seek of 5 and -3 2 to get the relative location from the beginning of the file. That can be. So look into this output. So as we have moved the 5th location, therefore the output it gives us this from 5 onwards it prints. Then next the 1 character. This is f dot read of 1, therefore 5. -3 2 it prints DEF. But the -3 2 the 1 character it prints the this. And if you want to give that for here, if you want to give print f dot tell, right? If you give this f dot tell over here and over here, just guess the output how much it will give. What is the output it will give to give this f dot tell? try to see over here. The after f dot seek of 5, therefore it is at the 6th location. The next character when you read, it's a 6th location. Then it is at the 16th location. Then from the D, the 14th location. Correct? Is that understood? The position that we have trained.
Yes, sir.
So the DEF it is printing, the end of file it is therefore 16. The last 3 characters 16, 15 and 14. So it is 14. Okay. So how to write into a file? So till now what you have read, that how to read from a file, move the pointer inside the file. Now question is that if I have some data, how to write those data into a file? How to write the data into a file? So if the data has to be written in a file, which mode we have to use? We have to use the W mode, write mode. In write mode, we have to use the to write into the file. So look into this example. File out equals to open. Then we have given the path. The file name is student.dat. The file name is student.dat. This is my file. Correct? And I open in write mode. That means the file is open for writing purpose. Then what I do over here, for I in range of 5, the value from 0 to 4. So 5 times what it will do? It will input the name of the students and write into the file. To write into the file, the function is write. The function is write. So file object dot write writes the content into the file. As you have not mentioned is a what kind of file, so therefore default is text file. The default is text file, right? So the name that you have entered, that will be written into this file. After writing the name, it writes /n character also. So that suppose you have inputted some name, like suppose you have inputted Ashok, right? If you have inputted some name, then press. So this name is being written. Along with that, the /n is also written into the file. So a value for /n is also written. So next name that you write, along with the ASCII value of /n will be written into the file. So like that, it will go on writing some names. How many names? 5 names it will write into the file, and then it closes the file, right? So the simplest, very simplest way of writing into the file. So it's very simple to write the content into the program. Just look over here. This is the file. I want to open this student.dat, a new file. I don't need to create automatically. W mode means it will create a new file. So this one, save it over there. Just look over here. It asks me enter the name of the students. I input a name over here. Correct? I input some other name. Okay, so how many times? 5 times it acts over here, and all those we have entered. Now you can see the file student has been is created, because our file name is what? File name is student.dat. The file name is student.dat. So student file on the desktop is created. File is on the desktop. So on the desktop, this file is created now, right? We'll check whether those content are being written or not. I just open it and check, yes, data is being written, correct? So this is one of the simplest way of writing into the file. Simplest way of writing, just open the file in write mode, input the content to the file. This is okay. But thing is that if I want to, there are many operations you can do. If I want to change this name to something different, or this name to be something different, then I have to move the file pointer over here. And then I'll go for writing the content, new content. So I have to move the pointer to a particular position. To move the pointer to a particular position, I will use the SIG. So therefore, we used to write, whenever we used to write records to the file, every record has a fixed length. So if I go to the end of the fifth record, then type into size of each record, so that I will reach at the end of the fifth record or beginning of the sixth one. So that operation also we can do. We'll go for those operations. I'll tell you that how to do, because suppose you are going for storing the data of a bank account. So how will you store those data in the bank account? I want to search for a particular account number, and I will do the modification for that account number only. So every account number is a record, and record has a fixed size. So I have to go to the beginning of that particular record and do modification on a particular byte. So two things to be known. One is the record number, so that record number into size of each record, I will move it to that record, and I will go to a desired location to have modification on those files, right? So therefore, the seek function and tell function plays a very important role of moving the file pointer inside the file. Correct? I hope you could understand that how to write into a file. Is it understood or not? All of you have understood how to write into a file?
Yes, sir.
Okay. Do remember, these are all important, because if you are going for, if I say to write, I am planning of giving you a small project for the last few classes, lab classes. So in those, if I say that to use a file, either I will say to use a file, or you will have an option to connect to the database and do, because after this file, I'll tell you how to connect to the database. So in any one of these has to be used over there, correct? So so therefore, understand it very keenly. This is one more example of writing into a file. So the same file I have the W mode, the write mode I want to open. The same another. So what will happen? The moment you open this file in W mode, the moment you open this file in W mode, what will happen? See over here, this is in W mode. The moment you open the file in W mode, whatever the content you have written earlier, whatever the content you have written earlier to this file will be erased or lost, and a new file will be created. Correct? If you want to add the content to the end of the file, instead of W, you will open in A mode. You will open in A mode for append. Correct? But suppose we open in W mode. We have a list over here. We have taken a list. For I in range 5, that means value of I will be 0, 1, 2, 3, 4. So you will input a name. You will input a name, and that name will be appended to the list. that name will be appended to the list. Are you getting me? This is a list. This is a list. It's an empty list. So how many times? 5 times it will input a name, and every time the name that you have entered with the along with the /n is added to this list. Are you getting me? It is not writing to the file. It is not writing to the file. This 2 line is just appending the names to this list. After the loop is over, then it writes this entire list into this file object, write lines. There is a method or a function called write lines, which writes the entire list into the file. What is the difference? Anyone, can you differentiate between the previous? In the previous case, we have inputted 5 names and we have written to the file. In
the previous, it was in the write mode, so all the content in the file will be erased when we open the file, but here it is in append mode, so nothing will be erased, and whatever we write inside the list, it will be just append in the end of the file.
No, my file will be in write mode. I'm not saying that it is in append mode. My file will be in write mode. So those 5 lines will be erased definitely. Whatever I have inputted, those will be erased, because I have, once you open in W mode, all my previous content will be erased. Understood? My previous content will be erased. Now question is that here, if you look at the previous example, I input a name and write into the file. I input the second name and write into the file. So 5 times I am writing into the file. 5 names I am inputting and 5 names I am writing. So every time a name is inputted, it is written into the file. But here it is not like that. I input a name, add it to the list. I input another name, I add it to the list. When all my 5 names are inputted and it is there in the list, now I write the entire list into the file. So I am writing once only. The list is written to the disk once only, but that list itself contains all the 5 names. The list itself contains all the 5 names. Understood? You must know that, you must be knowing that the write into the disk takes more time than writing to the memory. Disk is slower device as compared to your memory. Memory is very fast as compared to. So what we are doing, we do all append operation in the memory. We do all append operation in the memory, and from the memory we transfer it into the disk. We transfer it into the disk. So these 2 lines are in the memory, and this line will transfer into the. So I just need to transfer one, and you can see this line is not in this loop. This line is not in this loop, so this will execute only once. This will execute only once. If you want to check, I will show you that all my previous content will be erased and all my previous content and the new content will be written. File name is same. I have taken student.dat and I want to input some name and I just want to write it into the file. So I execute with the same. Enter the student name. I input some name like this. See, previously what I have inputted, Ashok, Sita, Rama, Tarini, Amarjit, all these have inputted. Now these are the new data. So as we are opening in write mode, all my previous content would have been erased. I'll check that. The student file, let me check. See, all my previous data are erased and the new content are written into the file. Correct? So what I am doing over here, I'm inputting a name and adding to the list. If you want to check what is the content of the list, we can print it over here also. Print list one. You will see, enter the name of the students, A1, B2, C3, D4, E5. Suppose this is, so this is my list. The list is A1 with slash n, B2 with slash n, C3 with slash, because slash n we have appended, right? So all these are there in the, so you can see over here, the file has now become A1, B2, C3, D4, E5. All my previous content are erased. I hope it is understood.
Yes, sir.
Yes, sir.
Is it understood or not? Okay. Okay, already it is time. So floss with example. The next class I'll tell you about the floss.